Okay, 8.2, perimeter and area of composite figures. What we need to do here is review some of the area formulas you have learned up until now. And that is area of a rectangle, which is length times width. So if you have an x and a y, what you would do is multiply x times y. Or, if you want to think about it, the way you learned it was area equals length times width. And that would be applied to also a square, because a square is essentially a rectangle, but all its sides are equal. Then we have area of a triangle, which is as follows, and you will be given the height and the base of the triangle, and the area of a triangle is base times height divided by 2. Now we have to calculate the area of a circle, and the area of a circle is equal to pi times the radius squared, pi r squared. The area of a parallelogram is essentially the area of two triangles, where you're given the base and a height, and the base times the height turns out to be the area of a parallelogram. The area of a trapezoid is as follows, where you have a top, a bottom, and the same height across. Well, that means the area is equal to half the height times top plus the bottom. And finally, the perimeter. Now, the perimeter of a shape, of a composite figure, is the sum of all the outside measurements. Now, the problem is not so much being able to add up, for example, the outside of a rectangle or parallelogram or trapezoid of those measurements, or even a triangle, but the circle in particular. You have to be able to look at the circle and say, okay, how do I find the perimeter around a circle, also known as the circumference? The circumference of a circle is equal to 2 pi times the radius. So all of these formulas are formulas you'd be expected to know leading up to this particular lesson. So let's look at some examples that can be applied. Example 1. You're asked to determine the area and perimeter of the following composite figure. So we have 15 centimeters, 48 centimeters, we have a height, and we have a certain base. Now, you could consider this as a trapezoid, or you can consider this as a rectangle plus two triangles. The reason why I'm asking you not to consider this as a trapezoid is you might not remember what the trapezoid formula is all about. If you do, then you know that, okay, you can take the area is equal to half the height, so half of 15, times multiplied by 65 plus 8 plus the 48. You can do it that way to calculate the area of this. But let's assume we don't have an area of a trapezoid. Let's figure out how to calculate this. Well, something to note that's really important is when I talk about the height being 15 centimeters, that means when we look at this particular diagram, we're looking at the height being here and the height being here. So what we have here is that this turns out to be our little rectangle with two triangles on the side. So what we can do here is split it up into pieces of shapes that we already know the area for. That is, area 1 is a triangle, area 2 is a rectangle, and area 3 is another triangle. And what we can do is find the areas of all three pieces. Area of 1, for example, is equal to base times height divided by 2. My base we need to figure out, well, we can do that by looking at the base right here, down at the bottom, and determine, okay, all of this is 65. I know this piece is 48, so going to here is 48. How much is left over? 65 minus 48 is equal to, 65 minus 48 times 15, and then divided by 2. So 65 minus 48 is 17, times 15 divided by 2 is 127.5 centimeters squared. So that is the area of triangle 1, or shape 1. area of shape 2, or polygon number 2, is a rectangle. So to calculate that, we use length times width just length times width. Length times width in this case is 48 by 15. 48 times 15 gives us 720 centimeters squared. And the last piece, area 3, is going to equal base times height divided by 2. Well, the base here is 8 times the height, which is 15, and we divide by 2, which equals 60 centimeters squared. So our total area of the entire composite figure is equal to 127.5 plus 720 plus 60, which gives us 907.5 centimeters squared. So that's the area of the entire shape. Now, what we need to do is determine the perimeter. To do the perimeter, what we're actually doing is adding up all the outsides. Specifically, we need to find this outside, let's call that X, and we need this outside, which we'll call Y. We need to find, if we know this measurement and this measurement, we can find the perimeter of the whole thing. How are we going to do that? Well, what we need to do is use Pythagorean theorem. We know that this is a right triangle, and the right triangle, where the right angle is, points always to the hypotenuse. So we can determine x by using the concept of Pythagorean theorem. I know that this measurement is 17. We figured that out by 65 minus 48. I know this measurement is 15 because of the height is 15. So 17 centimeters across here and 15 centimeters across here. We can determine the length of the hypotenuse. We do that using Pythagorean theorem, which is x squared is equal to 17 squared plus 15 squared. X squared is equal to 289 plus 225, which equals the square root of 514. And remember, folks, when we take the square root, we keep the answer to 4 decimal places. Next, we've used Pythagorean theorem to find the y value. Y squared is equal to 8 squared plus 15 squared. Y squared is equal to 64 plus 225. Y squared is equal to 289. Because y squared is equal to 289, we find out with the square root that y is equal to 17. What does that give us? Well, first of all, note what kind of special Pythagorean theorem this is. That's right, that's a Pythagorean triple, which we talked about in the previous lesson. Now, we have 17, we have 22.6716, and what can we do, folks? We can add up all the way around this particular composite shape. So the perimeter of the entire total perimeter is equal to 22.6716 plus 48 plus 17. So 22.6716 plus 48 plus this side, which is 17, not 15. Some of you might be trying to do that, but it's the outside, which is 17, plus 8, plus 65, gives you a total of 160.6716 centimeters. And that's the total perimeter of this entire problem. Okay, next we're going to move on to the next example. The next example is as follows. Ready? Part B. Now we have another composite figure, and here we have right angles, and we need to solve for this. Okay, so we have right angles in all 4 corners and right angle over here as well. And we also have some measurements given to us. That is, some measurements saying that there's 3 meters between here and here. We have 10 meters along the top, 7 meters along the sides. What I can tell you is this measurement is equal to this measurement. And on the other side, this measurement is equal to this measurement. We have 2 meters along the bottom. And that's it. That's all we're given. And we need to determine the perimeter and the area of this particular problem. So how are we going to do that? Well, what we need to do is divide this into 2 pieces. We know that this piece over here is going to be 4 meters. The reason we know it's 4 meters is the whole thing is 7. We We subtract 3 over here. We get 4 meters over here. I know this measurement will also be 4 meters because these two match each other. I know this side is 4 meters. So all the sides with the single ticks are 4 meters. And then the number along the bottom is going to be 10 minus this measurement. Okay, and how much is this measure? Well, 10 minus the 2 meters, minus the 2 meters. So these are these two pieces right here, so that we can find the measurement from here to here. So 10 minus 2 will equal 6 meters. How will that help us? Well, now we can divide this into two composite figures, two rectangles, one here and one here. And now we can find the area of the two pieces, area 1 and area 2. Area 1 is going to equal length times width, which is 10 times 7, which equals 70 meters squared. And then we have area 2, which is equal to length times width again, which will be 6 meters by 4 meters, which will be 24 meters squared. So my total area of this composite figure will be 70 plus 24, which is 94 meters squared. Now that we've done this, what you can do is now find the perimeter. We need to find the perimeter of everything. Well, that is, to find the perimeter, we start here and go 10. At the top, 10 plus 7 plus 2 plus 4 plus 6 plus 4 plus 2 plus 7. This whole side is 7. So we add that all together and we get 42 meters. So total perimeter is 42 meters and the total area of this composite figure is 94 meters squared. Example number 2. Let's look at a problem. So here we go. Diagram below shows a running track at a high school. The track consists of two parallel line segments with a semicircle at each end. The track is 10 meters wide and you have 84 meters here. So 100 meters across from here to here. And here to here is 100 meters across. We know the total width of the track is going to be 84 meters. I know that each part of the little part of the track, so is the tiny track has 10 meter wide track. And then we have in between here to here, we have 64 meters. We have 64 meters, folks, because 84 meters minus the 10 will give us the 64 meters inside here. And part A is to look at a person that runs around the inner edge of the track. So Ramona runs on the inner edge of the track. How far does she run in one lap? So this is all the information how to solve it. Let's go back and start this again. So we know that Ramona runs around the track on the inner edge, and we need to know how far she actually travels. So how do we do that? Well, we need to be able to mathematically prove this. So the inner edge means that Ramona runs around the inside edge like that of the track. Knowing this, that she runs on the inside edge of the track, we also know that there is a rectangle and two circles on either end. So a rectangle and two semicircles. So knowing that, what we do is we can find the area, the circumference of the first half circle plus the outer edges up here and here to add. And then part 3 is we add this circumference right here. So if we add all of these pieces together, we'll be able to determine how far Ramona runs when she runs the inside of the track. So here we go. We need to find the circumference of 1 and 3 together. 1 and 3 together will be one full circle because each of 1 and 3 separately is a half a circle. So we need to add 1 plus 3 together. Circumference of a circle is 2 pi r. What is the radius of the inside of that circle? Well, the radius is going to be 32. The reason it's, sorry, not 32. Yes, 32. The reason it's 32 is the whole diameter is 64 meters. Half of that is 32. So 2 times pi times 32, which will equal 64 pi. 64 pi, when we type it into our calculator after we add the total perimeter. So notice I'm not even touching the calculator here. What I want you to do is use pi the way it is. So you have a pi button on your calculator and you're going to use that. So the total perimeter will equal 100 on the inside plus the 64 pi, which is each piece of these, plus the 100 on the other side will give us a total of 401.0619 meters total. So that's the total perimeter that Ramona will run. So Ramona will run for just over 401 meters. Now, let's go on to the second part. What would part B be? Well, here we go, folks. Part B, same question, okay, but we're going to have a part B. Okay, so now we have part B. Evan runs on the outer edge of the track. How much further does Evan run compared to Ramona? So Evan now will run on the outer edge of the track. So that's the outside edge going around. We need to determine how much Evan will run compared to, how much more Evan will run compared to Ramona. So we have Ramona's information, which was 401.0619 meters. Evan will run a total of the outside of the track, and that is 2 pi r, that's the 2 half circles on the outsides, plus the top and the bottom, which is another 100 meters on both the top and the bottom. So plus 100 meters plus another 100 meters. So r in this case, in the orange track going around, is going to be half of the 84. So 2 pi times the 42 plus the 100, or plus the other 100, which gives you 200, and we can calculate the final value. That is, plug it into your calculator, and you will get 463.8938 meters. So therefore, we find out that Evan runs 463.8938 meters minus the Ramona's distance, which is 62.8319 meters total, more than Ramona. So this is how much Evan will run more than Ramona. Okay, this is how much he runs. This is how much Ramona runs. We subtract the two values to find out how much excess or extra Evan will run because he's running on the outer edge of the track. Okay, now we're going to look at part C of this same question. Okay, part C says the track needs to add a new layer of surface compound. It costs $50 per meter squared. How much will it cost to resurface? So literally the track surface is that inside layer right here. So if I'm just going to take a little highlighter and highlight all around that inner layer, we need to basically find out how much it will cost to resurface that inner layer. How do we do that? Well, what we need to do is find the area of the total outside and subtract the area on the inside to determine the remaining area. That is, find the area of the outside, pi r squared plus length times width, the outer part, and subtract the inner part. Okay, now area, remember, so we need to do the outside minus the inside to find the remaining edge around. And that is pi r squared, r from the outside was, the radius was 42, plus length times width, which is 84 times 100, minus pi r squared plus 64 times 100. So, one more time again, this is the area of the outside part, which we have to add together. So we add those pieces together, and then we subtract the inner part, which we add together, these pieces right here. We take the outer minus the inner part to be able to determine how much track there is. So, we find out that there is an outer track of 4,324.7786 meters, and we subtract meters squared total. Sorry, this is the total. So the outer part minus the inner part will turn out to be 4,324.7786 meters squared. Now, again, if we're buying parts to something, you have to understand that we're not going to be able to buy part of something. We have to buy the whole thing or nothing at all. So in this case, we need to purchase a total of 4,325 meters squared of parts. So knowing that we need to buy 4,325 meters of parts, we can now take that and multiply it by $50. So the cost is going to be $50 times 4,325 meters squared, which will give us a total of $216,250. So therefore, it costs $216,250 to resurface the track with a particular surface compound. All right, folks, well, that's the end of the video. Have a numerical day.